Welcome to the revision session for week 9. In the earlier session we have done up to the week 7 and net, and there are some important points which is related to week 7 and net, which are: first we will see some properties of sequence. A lot of people are having doubt in GIF, or you say float function, and the third one is how will you determine whether a function is differentiable or not at a particular point. Okay, so the first is sequence. Okay, so we are not going to deal with what is sequence and such stuff. So we will be looking at the most important points related to sequence. So there are two types of sequence, that is convergent and divergent. So let us suppose any sequence an. So if limit n tends to infinite for sequence an is a finite number, then this is called as convergent sequence. Otherwise, in all cases it is divergent. So in the earlier session we have solved 5 questions based on finding the limit of sequence. So these are the main two properties which I left in the previous session. So n tends to infinite. If it is a finite number, then it is convergent. In all other cases it is divergent. So let us take one example, that is let us suppose an is given by 1 by n. Okay, and is n starting from 1, so it will be 1 by 1, 1 by 2, 1 by 3, 1 by 4, and it goes 1 by infinite, that will give 0. So it's giving finite number, so it is a convergent sequence. Whereas let us take another example for n. So it is -1 to raise n, 1 by n, so it will give like -1 by 1, 1 by 2, -1 by 3, 1 by 4, and so on. Okay, so finally it will be some number, either positive 1 by infinite or negative 1 by infinite, that will give 0. Okay, so this is also a convergent sequence. So now let us take one example. So let me add one slide more here. Okay, so now we are taking to, so now we will look about divergent sequence. So let us suppose any sequence an is given by -1 to raise n, only -1 to raise n. Okay, so it will be like -1 1 -1 1 -1 1. So if we take it to infinite, so it will give either -1 or 1. So it is not giving any finite number. Okay, so this is a divergent sequence. So in convergent sequence, only one finite number exists. Okay, when n tends to infinite. In all other cases it will be divergent. Okay, so here for when n is even it is positive, and when n is odd it is -1. Hence -1 to raise n is a divergent sequence. So there are some properties. So properties are, so let me write here. So the first property is an plus bn. If there are two sequences an and bn and both are convergent to a and b, then they will converge to a plus b. Similarly, a and bn are convergent, then they will convert to a times b. A minus b, they will converge to a minus b. So these are some properties. And for divergent sequence, only one point you should remember is the subsequence of divergent sequence is both convergent and divergent both. But in the case of convergent sequence, the subsequence is convergent. Okay, so the last point is very important, so remember this point. So now moving to the GIF or float function. So a lot of people are facing problem in GIF. So I call it GIF, or some other people call it float function. GIF stands for greatest integer function. And it is denoted by like this. Okay, so first we will draw graph and we will transform it. Since we are already familiar with transformation of graph, then we will try to transform GIF as well. Okay, so let us suppose this is X and this is Y. So here it is 1 2 3 4 1 2 3 4. So the graph for greatest integer function is, so let us understand greatest integer function by graph, so it will give you more clear idea about it. So we will define it the interval 0 to 1, 1 to 2, 2 to 3 and 3 to 4. Okay, so in the interval 0 to 1 its value. Okay, so greatest integer function only takes integral value, remember it. So from 0 to 1 it is 0, so from 0 to 1 not including 1, so it is 0, and from 1 to 2 it is 1 excluding 2, from 2 to 3 it is 2 excluding 3, and 3 to 4 it is 4 excluding 4. Okay, it is 3 2 1 0, and in the negative one, so let me draw for the negative value of x. So from minus 1 to 0 it is minus 1. Okay, excluding 0. From minus 2 to 1, so this is minus 1 minus 2 minus 3, so this is minus 2 minus 1 and minus 3, and from minus 3 to minus 2 it is minus 3. Okay, so remember this graph. Now we are going to transform it. Okay, so this is the graph for x, and when we draw x by 2, since this takes only integer value, so its range will be only 0 1 2 3 4, such like that. Okay, so when it will be 0, so x by 2 will be 0 only when x by 2 is less than 1, that means x is less than 2, and it will be equal to 1 when x by 2 is less than 2. Okay, or similarly x by 2 will be less than 3, then it will be 2, and x by 2 will be less than 4, then it will be 3. Okay, so from here x will belong from 0 to 2 excluding 2. Let me use different color, so it will give 1 only when x will be less than 4 and should be greater than 2 and equal to. Okay, and x will be less than 6 and x will be less than 4. So I am not taking the left hand value for this x, we are just generating for maximum value for x up to which it will take integer value. Okay, so let us try to generate graph for x by 2. Okay, so this is our x axis and this is y. Since this take only integral value, so 1 2 3 4 and 1 let me draw for more value. Okay, so in the earlier slide we have found that from 0 to 2 it will be equal to 1, so let us use here 2, and from 2 to 4, so it is 4, it is 6, it is 8 and 10. Okay, so from 0 to 2 it will be 0 excluding 2, from 2 to 4 it will be 1, from 4 to 6 it will be equal to 2, and from 6 to 8 excluding 8 will be equal to 3, and from 8 to 10 excluding 10 will be equal to 4. Okay, so this is how this graph looks like. So this is discontinuous. Okay, so since this is discontinuous, then it is not differentiable at 2, 4, 6, 8, 10. Okay, and it is discontinuous at this point also. So this is continuous at 1 and also differentiable at 1. Okay, but this is not continuous at 2, 4, 6. So since this is discontinuous at these points, so it will be not differentiable at this point. Okay, so from here we can generate one conclusion that x by 2, when x is even in the case 2, so its value is 1, so it will be equal to x by 2. When x is odd, so put x here, so let us suppose x is equal to 3, so it will give 1.5, and GIF for 1.5 is 1, so that means it is equal to x minus 1 by 2. Okay, so just try to play with a graph, so it will give you a very good idea about how a function behave when its characteristics changes. Okay, so that's why I have uploaded that video. So watch that video. I didn't discuss GIF in that particular video, but will give a very basic idea about how to transform a graph. So we have transformed it from only x by 2. We can also generate x, 3x, 4x, sine of x. Okay, so you can play with it. So now moving to the last one, that is how we will determine whether a function is differentiable, continuous or not. So now moving to the condition for differentiability. When any function is not differentiable. At a point. Okay, so the first condition is the function is not continuous. Okay, that means there are some missing point here. So let us suppose this is the function and we want to differentiate it at the point x is equal to a, and at this particular point its value is here. Okay, although its limit exists at x equal to a, but this is not continuous, so this particular function f of x will not be differentiable at this point. So this is the first condition. The second condition is there is a bump in the curve. That means sudden rise or fall. So let us suppose a particular function looks like this one. Okay, so from here and it is like this. So if you want to differentiate at x is equal to a, although it is continuous, but this particular function f of x is not differentiable at x equal to a, because the f dash of a minus is not equal to f dash of a plus. Okay, so there is a bump here. The third condition is Third condition is like, let us suppose this is some particular function, okay, f of x. So when we want to draw tangent here, so it will be parallel to y-axis. So at this point this function will not be differentiable, okay. So these are three conditions when any function is not differentiable. So in most of the cases this condition and this condition stops any function to be differentiable at any point, okay. And for continuity, the missing points stops from being continuous, okay. We have understood about GIF, floor function, its all the properties of divergent, convergent, okay. So now moving to the week 9 content. So in the week 9 we are only dealing with critical points. We have to find local maxima, local minima, how we can find global maximum or global minimum, okay. Then we will go to Riemann sum and integral and area under curve. So first we will understand what is critical point. So critical points are those points where the derivative of that particular function is 0, okay. So let us suppose there is any function like this, okay. So this is x and y axis. So at this point, this point, this point, this point, the derivative is going to 0. So how we can find the local maxima or minima, okay. So first we will find first derivative and will equate it to 0. So now there will be many points and there will be many value for f dash of x for which f dash of x will be equal to 0. In this case there are 4 points. So let us suppose this is 1, 2, 3, 4, okay. So now you will again differentiate it. So we will check the value of f dash of 1, f double dash of 2, f double dash of 3 and f double dash of 4, okay. So if f double dash of a is greater than 0, then at that point minima will achieve, and when f double dash of a is less than 0, then at that point maxima will achieve, okay, local maxima. So there are 4 points here. So what we'll do is one by one we'll check. So there will be 2 points where it will be less than 0, because here and at this point, and at this point and this point it will be greater than 0. So now we will substitute the point 1 and 3 in this particular function f of x, and then we will compare. So we will find f of 1 is greater than f of 3. So particularly at the point 1 local maxima will achieve, and at the point 2 local minima will achieve, okay. So this is how we compute local minima or local maxima. So now moving to the application part of it. So there is a rectangular sheet of tin made up by, so its length is 45 centimeter and its breadth is 24 centimeter. So it is made into a box without top, okay. So by cutting off a square from each corner, so it has been cut, and folding up the flags, so okay. So it is folded like this one. So this part is the, and finally it will become like this, okay. So what should be the side of the square to be cut so the volume of the box is maximum? So let us suppose this side is x, so this x, okay. So its length will be reduced by 45 minus 2x, and the breadth will be 24 minus 2x as well, okay. X from here, length from 2x, okay. So what should be the side of the square to be cut so that the volume of the box is maximum, okay, and its height will be equal to x. So this part will rise, so this part will rise, also this part, okay. So multiply it. So volume is equal to 45 minus 2x, 24 minus 2x times x. So it will be equal to x into 24 minus 2x and 45 minus 2x. So what we'll do is basically a rough idea about it. So at x equal to 0, x is equal to 12 and 22.5. so this will give a part. Since this is a 3-degree polynomial, so we'll start from 0, then we'll achieve maxima, minima and maxima. So in the point between 0 to 12, so volume will be maximum, okay. So differentiate it. So b dash will be equal to, so the maxima will achieve in the range 0 to 12, okay, by looking at this curve. So this is how cubic equation looks like. So now we will find derivative for volume, okay. So volume is equal to x times 24 minus 2x into 45 minus 2x. So let me use different color. So it will be equal to 2x times 12 minus x, 45 minus 2x, which is equal to 2 times 12x minus x square and 45 minus 2x. Now we are ready to differentiate it. So v dash will be equal to 2 times 12 minus 2x times 45 minus 2x plus 2 times 12x minus x square times minus 2. So now we will multiply it. So it will be equal to 2 times 6 times 90, 540 minus 12 times 2, that is 24x minus 90x, okay, plus this is 2 times, so it will be basically minus 4 times 12x minus x square. So it will be equal to 1080 minus 24 and 90, 114, which is 228x minus 48x plus 4x square. So it is equal to 4x square. Also here it is 8x square from this term. So it will be equal to 12x square minus 276x plus 1080. So take out 12 as common, so x square minus 23x plus 90. So now we will equate it equal to 0. So x square minus 23x plus 90 is equal to 0. So it roots will be 18 and 5. But earlier we have found out that its value. So the maximum value will lie between 0 to 12. So from 0 to 12 only 5 is here. Only 5 lies between 0 to 12. So 5 lies between 0 to 12. So the length of the side for the square is equal to 5. When we cut the side of the square is equal to 5, then the volume of the remaining rectangular sheet will be maximum, okay. So there are many problems in the graded assignment as well as in a practice assignment. So you should solve all those problems. So there are 5 problems based on maximum, maxima and minima in the NCERT. Solve all those problems, okay. So now we are done with critical points, local maxima and local minima. Now we are going to Riemann sum and integral. So Riemann sum is basically summation of point using rectangles or trapezium. So let us suppose any curve is like in this form. So this is 2 state, like this one, okay. And now we want to compute area between A to B. So either we can distribute in the form of triangle or form of rectangle, in many interval, okay, and then we can compute. So there are only main 3 points to compute area of any curve between A to B. So the first is left hand, the right hand, and the middle point. Okay, so in the left hand you have to take limit the way you have to take the height of the rectangle at x is equal to a, and for this interval it will be a plus h, for this interval it will be a plus 2h. okay, so like in this form. So area will calculate like in this form. But when you take the right point as the height of the rectangle, then its area will be like this from here. So its area from here, okay, like this. So basically Riemann sum is basically 𝗕𝗵𝗀𝗁𝗕 calculation. So just practice it from the assignment. So there was a question in the graded assignment as well as in practice, and there is one question in the mock for quiz 3. So do attempt. We are not going to compute it here because it will be more linear, and there are many more points that we have to cover in this particular video. So we are done with the Riemann sum, and the most efficient way to find integral is from the middle, that means by using trapezium. So the most efficient way to calculate area is using trapezium. So how we will calculate as, let us suppose this is the function and we want to calculate area from A to B. So what we'll do is we'll take trapezium from this point to this point, then this point to this point, and from here to here. Okay, so this is the most finest way to find the area. Okay, so how we'll compute area? So what we'll do is find the tangent here at the middle point, or basically we can find f(x star), which is equal to f(xi) plus 1 minus f of xi divided by 2. okay, and then we multiply it by length of the interval delta x and the sum, which will give you all the area. So basically this will check your calculation, and now there are much more efficient way to calculate, and there are many powerful tool available for calculating some 𝗕𝗵𝗻𝗁, calculating area of some 𝗕𝗵𝗻𝗁 function. So now moving to the last topic, which is area under curve. So basically area under curve includes, which requires two skills, that is the graph transformation and you should know integration of some basic function. Okay, so let me write some basic integration of some basic function, that is we should know what is the integration of this particular function. Okay, and we have already seen the graph transformation in the earlier session. Okay, so now moving to so there is one important method to find integration, that is integration by parts. So basically if there are two functions u and v, and we have to find integration of u v dx, so what we'll do is we rename these two functions as first and second, and what we'll do is take out first and integrate second, then differentiate the first one, integrate the second one, then whole integration. Okay, so this is called integration by part. So there is some priority basis that is given to this function based on IIT. So IIT stands for I for inverse, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential. So let us suppose we are trying to find x log x dx. Okay, so what we will do, so we will go through this list. So this is the decreasing priority. So first we will give priority to inverse, then log, then algebraic, T, then exponential. So log comes first before the algebraic, so log x will be the first one and the x will be the second function. So let me write log x and x dx. So take out log x, integrate it, x dx minus d upon dx of log x times integration of x dx, the whole dx. So it will be equal to log x, x dx is equal to x square by 2 minus differentiation of log x 1 by x, integration of x dx, so it is equal to x square by 2, the whole integration. So it is equal to x square by 2 log x minus x by 2 dx. So x by 2 dx will give x square by 4. So finally it is equal to x square by 2 log x minus x square by 4 plus some constant. Okay, so this is how we calculate integration by parts. So there are many more methods to find integration, but due to time constraint we are not going to deal with the other method. So in this particular course we are not going to deal with a very rigid method to find integration. So this particular course mainly consists of some basic or elementary application of integration. So I think these videos will suffice your need for the quiz 3. So now we will end this session here. So thank you.